Nerd. Okay, 6.54. A 20 kilogram rock is sliding on the rough horizontal surface at 8 meters per second and eventually stops due to friction. The coefficient of friction, of kinetic friction, between the rock and the surface is 0.2. What is the average power produced by friction as the rock stops? So, we're gonna take this. Let's write down what we know. Mass equals 20 kilograms. Kilograms. That's 20. Mass equals 20 kilograms. V naught equals 8 meters per second. V equals 0. And the coefficient of friction is 0.2. Sweet. So we know that power equals work over delta T. So if we can find the work and the time, change in time, then we can do it. Work, we know, is 1/2 mv squared minus 1/2 mv naught squared. V is 0, so we get work equals 1/2 mv naught squared. V naught is 8. Plug that out and you get negative, it should be negative 1/2 mv naught squared. Negative 640 joules. So then, we also know that work equals negative F delta X because the force is in 180 degrees from the change in displacement, change in the position. So we get work equals negative F delta X. For our force, we get friction force, we get equals 0.2 times mass times gravity, 20 times 9.81 equals 39.224 newtons. So then, we can use that to find delta X. So, work equals force, negative force times delta X. Delta X, we plug in, it's going to be work over force, negative force. We get 640 all over 39.2 equals 16.3 meters. So then we can take delta X equals V delta T times delta T. Solve for delta T. Delta T equals delta X over V. And plug stuff in, you get 16.3 divided by 8 equals 2.04 seconds. So then we take that, say that power is equal to work all over delta T, which equals negative 640 all over 2.04 equals negative 313.92 watts. Cool.